Okay, let's see. Problem. This is problem number 4. So this is an island has 3 species of birds. Species 1 accounts for 45% of the birds. So now the first thing I want to do is write down the information I know, right? Probability of species 1, let's call it S1. Probability of species 1 is finding it on this island is 0.45. Probability of finding, of those, 10% have been tagged. So an island has 3 species of birds. Species 1 accounts for 45% of the birds. Of those birds, 10% has been tagged. So, you listen how I said that? This is the intuition you have to build in your own head if you're yourself saying. So, species 1 accounts for 45% of the birds. That's what I drew. Then it said, of which, meaning of those birds, of species 1, 10% have been tagged. So, given that it's species 1, they have been tagged. Species 2 accounts for 38%. ES2 equals 0.38. Of which, of those, 15% have been tagged. Is this helping so far? 1, 4, 5. Species 3, come on. I'm recording this, so just to let you know. Species 3 accounts for 17% of the birds, and of those birds, of those species, 50% have been tagged. Notice something. 0.17 plus 0.138, I'm sorry, 0.38 plus 0.45 is what? What's this plus this plus this? Not right, 1. Because that's all the possible outcomes I have. I only have 3 birds, 3 types of birds. So the sum of their probabilities has to come up. That's the entire set. Okay, because we're dealing with this time. Now it says, if a tagged bird is observed, okay? So given that you get a bird and you see it's got a tag, right? So given that a bird is tagged, what is the probability that it is of species 1, of species 2, and of species 3? Now, you can't have a bird that's all 3 species, right? So what the question is, what's the probability for each one? What's the probability that it's species 1, given that that bird happens to be tagged? And of course, you need to use Binney's theorem, and you have all the pieces that you need for Binney's theorem. You have the probability of S1, so I'll just write that. Probability of species 1, that's given times the probability of being tagged, if it were species 1, you're given that, divided by the probability of it being tagged at all. Probability of it being tagged at all. And so, you have to figure that out. How do you find out the probability of it being tagged if you don't have that information? You got to break it out just like you do with the other. Okay? So that now you have 3 species, so that one way you can write this is by representing it as probability of being tagged and species 1 plus the probability of it being tagged and species 2 plus the probability of it being tagged and species 3, because the sum of all those things is thus simply. Another way to write that is this is the probability of being tagged. What's the probability of being species 1 times the probability of being tagged plus probability of species 2 times the probability of being tagged plus, this is the law of total probability of some ways, but that. And of course, another way to write that is using this notation. To say I equals 1, 2, 3, for example. Probability of SI, meaning species 1, species 2, and species 3, times the probability of being tagged given there are species 1, 2, or 3. And this is nothing to do right there, and that's the other way you see here. Okay? Yes, exactly the same.